Here we have a simple biofeedback example. On the left side we have Wizard, which is software used for virtual reality but also two-dimensional biofeedback. And on the right side we have Acknowledge. In Acknowledge we're recording a respiration signal. We're going to use playback in this example. And on channel 1 we're going to have the raw signal. Channel 40 it's filtered to remove any baseline drift, and channel 41 shows the derivative of the respiration signal. So when the person is inspiring, we want to have some visualization in the script here, and when the person is expiring, we also want to have some form of visualization. So let's open up our script. Okay, now what we're gonna see happen here is these tiles will start shimmering in different colors of blue when the person is inspiring, and they'll be getting colored in various shades of red when the person is expiring. And also, depending on the intensity of the inspiration or the expiration, the balloon is going to move up and down. Okay, now we have started the script. Let's change the scaling here in Acknowledge so we can have a better look at the signal. So now we can see as soon as we cross the threshold above 0, we start getting the blue tiles, and the red tiles are animated when we are below 0. And again, this is the derivative of the respiration signal. So it's when we are actually inspiring is when the signal is above 0, and when we are expiring, the signal is below 0. If we view the actual respiration signal, we can see this relationship a bit better. And we can, in fact, overlay the signals on top of each other. So we can see here how the black line, the derivative, is crossing with the red line, which is the actual signal for the respiration. And now when we're finished, we'll just go ahead and hit escape. And again, the Wizard software is going to control remotely what happens with Acknowledge. So it's actually going to stop the acquisition. Now let's have a look at some of the components of the program. Here we have different libraries that are required for the code to execute. Then we have variables related to, for instance, the server is keeping track of whether we have started Acknowledge data server. The weight variable over here changes the weighting of the coloring effect that we're doing for the visual display. And we're also performing normalization of the effects. So we're doing this in real time. So if the person takes a very deep breath, now we are counting this as sort of the maximum breath, and we will adjust any effects based on that. And this adjustment variable is just allowing us to make effects more or less pronounced. Now in Acknowledge, we can stream various channels. We can stream analog channels or calculation channels. These are the channels that begin with index 40 and higher. And here we're just keeping, we're storing the index of the channel from which we want to get the data. So, and we start from 0. So this is 0, 1, 2. We're getting data from channel 41, which is the third channel in the overall count. Starting from 0 is channel number 2. So we're getting the data from the difference calculation, which is the derivative of the respiration signal. Well, here we have various items for visualization. We can also have a picture that changes with the status of inhalation versus exhalation, and we've disabled this right now. So we've actually made this picture not visible. This is what this line does. So this is just an option in the program we're not using right now. Okay, this is where we add the balloon object, and you could really use any sort of object. .osgb is the preferred format, and in this particular example we've just taken an object from sketchfab.com, just a royalty-free object, and we have imported it to use in Wizard. Here we're setting the position of the balloon, and we're also changing the orientation so it's facing the user. Okay, then we have a function to process the NDT data. This is a function that processes data that's coming in from acknowledge. Okay, and that's where we're making use again of that weight variable. So we're taking the data, whatever data his sample has currently just come in from the derivative of the respiration, and we are assigning it to the variable weight. Okay, and we are changing the position of the balloon. This is the horizontal, vertical, and depth position. So we're changing the vertical position of the balloon depending on the weight. So depending on the value that's coming from the derivative of respiration. And we're also amplifying that change by adjustment times 2. This is arbitrary. This is just depending on what we need for the visualization to work out for us. Further down, we are performing a normalization of the weight value. We're keeping track of the maximum value so far. So the biggest change in respiration so far. And if we have exceeded that change, we are making the new number be equal to the max value. And then we're taking weight divided by the max value. So we're always going to work with a number that is no bigger than 1. Now, if we are in the positive phase of the derivative signal, we're obviously inhaling. So what we're going to do then is we have a variable here for blue tiles. These are the blue tiles that we saw on screen, and we'll go over how those are getting created. So for the blue tiles, we'll change randomly their transparency value. That's what the alpha is for. And how transparent they are will depend on the weight and the adjustment. And we're making all the red tiles invisible because the red tiles correspond to exhaling. Okay, and then we do the exactly opposite thing in case we have a derivative of respiration that is below 0. Okay, this is the line, single line that is sufficient to connect us to acknowledge, and here we're just checking to make sure that we actually were able to connect to an acknowledge data server. Here we're setting up a connection method to acknowledge, and these are just standard commands we use for setting up communication with acknowledge. And we're also registering this function process NDT data, the one that we went over right here, as a callback. Okay, so this is a function that's going to get called up whenever data come in. Okay, I'll make this screen a little bit, make the visit screen a little bit bigger now, so it's easier to read the code. Now here we have a function called make square, and we use this to create the little tiles that we're animating. So these are objects created on the fly. So here we just specify the vertices of the objects in 3-dimensional space, and then we assign a color. So when we call this function, we can specify x, y, z coordinates, and then the length of the side of each square, and then the RGB value. And we're going to have two kinds of tiles, blue tiles and red tiles. And we're going to go ahead and create them. So we want 100 tiles, 10 in the horizontal direction, 10 in the vertical. So this is simply saying do 10 tiles from in the horizontal and 10 in the vertical direction, and we're going to make a blue tile and a red tile, and these are the coordinates. So we have x, y, and these x and y will change between 0 and 10, and then we're putting them 25 meters away from the user. And these are the RGB color codes at the end, and 0.05 is the length of each side of the square. Now if we make this equal to 1, everything's going to look like a solid wall, so we actually left some space in between the tiles. Okay, 0 in the first value for the RGB code means this is the value for red, green, and blue. So these are the blue tiles. They're not absolutely blue. They're a mixture of green and blue. And here we have the RGB value for the red tiles, which only have a red component, 0.6, and these numbers go up to 1. Okay, this is how we can make the tiles random with the random transparency effect. This is actually not even used anymore. It's overridden by other functions. It's all function that remains. So just a few more things left in the program now. We have a data button that we're creating. It's just a button. That's the button we're going to use to start remotely the acknowledge acquisition and the data server. Okay, so here we're saying, let's create a button, let's place it on the screen in a certain location, let's scale it, and let's assign a picture to it. Okay, and then we have a function. So this function on button is going to get called whenever a button gets pressed. So we currently have only one kind of button, so we don't even have to check what kind of button was pressed. So we're going to allow this button to be pressed only once. So once it's pressed, we're going to make it invisible. Okay, and if we have an acquisition in progress, we're not going to do anything. But if we don't have an acquisition in progress, we'll start the acquisition. And no matter what, we'll start the data server. So we have two things we have to do. We have to start the acquisition and we have to start the data server. So we have to get acknowledged to start sending data over the network. Okay. All right. So, and then this is the callback for this button function. This enables the interactivity with the button. And this function here, by, it simply tells the software on exit. So when we're hit escape to exit the program, what to do. So we want to stop the data server, and if the acquisition is still ongoing, we want to stop the acquisition. So we're just tidying everything up. This.go starts the program, and that's basically it.